graphs of the other trig functions. This video is a follow-up to the video on the graph of the sine function. So let's look at the unit circle here and suppose that we want to do the graph of y equals the cosine of theta. Well, in order to graph that, we'd have to come up with the coordinates that we'd find as we progressed our way around the unit circle. So for instance, the cosine of 0 radians, remember the cosine equals the x value on the unit circle, so that would equal 1. So for our graph of the cosine function, we would have 0 radians corresponds to 1. Here at pi over 6, since the cosine of pi over 6 equals square root of 3 over 2, what we'd have would be pi over 6 as a cosine of square root of 3 over 2. And see, if we just keep going around, we'd have the angle followed by the first coordinate on the unit circle. If we take all of those and plot them, we get a graph that looks like this. Now, just like the sine graph, it would keep going infinitely in both directions, so I've just shown portions of it. Notice that if we start here at 0, 1 and trace our way through this cosine, if we keep going in either direction, we'll just have a repetition of what we found here. So the period would go from 0 to 2 pi. So the period of the cosine would equal 2 pi. Transformations can be done on the cosine just like in the last video we did transformations on the sine. And notice here that the formulas are exactly the same as those for the sine. If y equals a times the cosine of bx minus c, the amplitude is the square root of a, the period is 2 pi over b, and the phase shift is c over b. So let's apply that to an example. Suppose we have y equals 2 times the cosine of 1/2 x plus pi over 4. So looking at our formula here, first of all, notice that a equals the 2. B, the number in front of the x, is 1/2, and c is minus pi over 4. You might mistakenly think that it's pi over 4, but on the last slide, this was minus c, so you need to essentially change the sign of it. Now our amplitude would equal the square root of a, so it's 2. Our period is 2 pi over b, and since b is 1/2, this is what we'd have. We would take 2 pi and multiply it by the reciprocal of 1/2, which would be 2 over 1. So that means our period is going to be enlarged. Instead of being the normal 2 pi, it's going to be 4 pi. And our phase shift is equal to c over b, so that would be minus pi over 4 divided by 1/2. Now that's multiplied by the reciprocal of 1/2, which would be 2 over 1. We can reduce, and we'll have minus pi over 2. This is what results. Notice that since the amplitude is 2, it goes to a height and a depth, 2 and negative 2. Whereas the basic cosine curve would have started here on the y-axis and gone down. Notice instead we're starting over here, which is corresponding to minus pi over 2. So that is our phase shift. And on the previous page we found that the period turned out to be 4 pi. Well, notice we go from here at minus pi over 2 up to 7 pi over 2. How far apart are they? Well, we could subtract them. 7 pi over 2 minus on the left negative pi over 2. Upon adding, we'd have 8 pi over 2, which is 4 pi. So sure enough, our period here is 4 pi. Going back to the unit circle, we can also do graphs of the tangent, cotangent, cosecant, and secant. In a similar way, we just have to go around the unit circle and find the values of these functions corresponding to the angles. I'll just give you an example of how that would look. Suppose we chose this angle here, pi over 3. Well, if we wanted to know the tangent of pi over 3, remember the tangent is the sine over the cosine. So it would equal the square root of 3 over 2 over the 1/2. Now when we go and multiply by the reciprocal of the 1/2, notice we'd have just square root of 3. So on the tangent graph at pi over 3, we would go up square root of 3. On the other hand, for example, if we were to do the cotangent of pi over 3, well, we know that the cotangent is a reciprocal of the tangent. So it would be 1 over square root of 3. We would rationalize the denominator and get square root of 3 over 3. So for cotangent, the point corresponding to pi over 3 would be square root of 3 over 3. Now to do the graphs of these, or for that matter the secant or the cosecant, we would just rather laboriously go around the circle and list all the values. I'd like to just show you what the pictures look like if you do that. The graph of the tangent function here, let's notice that it keeps repeating itself, and the basic period could be considered here. In other words, just one period of this graph could be what you get between negative pi over 2 and pi over 2. That gives a period equal to pi. We also have a frequent occurrence of what we call a vertical asymptote. A little difficult to draw it in here, but there's a vertical asymptote at pi over 2, 3 pi over 2, and also here at negative pi over 2 and at negative 3 pi over 2. So we have vertical asymptotes at odd multiples of pi over 2. If we look at the cotangent, notice it's a similar shape, but sort of an inversion. Here we have our vertical asymptotes at pi, at 0, at minus pi, at minus 2 pi. In other words, every multiple of pi, we get a vertical asymptote. And notice the period of this is also equal to pi, because you can draw one repetition of its basic shape here between 0 and pi, and you simply repeat if you move to the left or to the right. Cosecant, we also get vertical asymptotes. Again, those vertical asymptotes come about simply when you have a division by 0. And so here we have vertical asymptotes at pi, 0, minus pi, minus 2 pi. That is all multiples of pi, even 2 pi over here on the right. Now let's figure out how long the period is. So let's just trace out the basic shape. We get this U-shaped graph here. But then if we move over, we get it occurring below the x-axis. Then if we moved over again, we'd get a repetition. So we say that the period would have to be the width corresponding to both of these U-shaped curves. And notice that goes from 0 to 2 pi, so the period of the cosecant is equal to 2 pi. And finally, the secant looks like a rather similar shape, although you notice things aren't occurring in the same positions. Here our vertical asymptotes are at pi over 2, 3 pi over 2, that is odd multiples of pi over 2. Same thing in the negative direction. And what would be the period here? Well, you'd have to go from negative pi over 2 all the way over here to positive 3 pi over 2. That is a period equal to 2 pi also. So in this video we looked at transformations of the cosine, which were done in an identical way to the transformations of the sine, and I just gave you a very quick look at the other 4 trig functions and their graphs. All right, signing out. Good luck.